All right. So I hope everybody can hear me and you can see my screen as well, right? Okay. So let's start. So what this talk is about is it's basically about the most common vulnerabilities that are usually identified in today's penetration testing while testing .NET applications and why certain bugs occur and why do and how do we fix them. So uh, uh, prior disclosure to before we get into the talk, I was not a full-time programmer. I have not done programming before. Actually, I got into this thing after conducting a lot of penetration tests on the web application and just to try to make sense why developer do certain things and why XYZ issue occurred during in a specific application. Just to figure out what's the developer was thinking while developing the application and what might he have done wrong to cause such issues. So a little bit about me. I'm a penetration testing consultant. I'm working as a private contractor right now, and I've been working for financial organizations, government organizations, oil and gas sectors, and whatnot. So that's pretty much it about me. And I've been into pen testing for like past 5 years or so. And recently I got into this thing to understand, to get a better understanding of why bugs occur in the application. So I decided to write a few set of vulnerable codes myself in order to understand why these things happen. So this talk is going to cover a lot of issues that I personally experienced during pen test, and how we can fix them. We will be looking into code a lot of times, and we'll be spending a lot of time in looking into codes and seeing what one line change can do. So let's get into it. All right. So the most common issues that are identified usually when testing a .NET application is like it's 2020, but still I've seen a lot of applications that are not using secure channel. They are still deployed over HTTP, and they are still communicating over HTTP. So pretty basic stuff, but yes, it's 2020 and we are still seeing clear text issues in production applications as well. All right, the next one is authentication and session management. The other issues is we identify a lot is access control issues or broken access control, or you can say insecure object references, things like these. So this is one of the most common issue found in .NET application. A lot of input validation issues, for example, SQL, XML injections, cross-site scripting, deserializations, sometimes command injections as well, template injections. Another most common category of issues that are identified while testing .NET application is the file upload. CSRF is not that common nowadays, but it's quite prevalent. Open redirect, yeah, it's still there in a lot of .NET applications. Misconfigurations and information disclosures. Okay, all right. So this is basically related to like informative headers enabled, and then how easy we will get into it and see how easy it is to fix those minor issues as well. All right. So I will just quickly go through the insecure communication channel. And basically what it does is your application is deployed on a server, but the server is not configured to use secure transportation medium. For example, a TLS certificate is not deployed, and your application is running over HTTP protocol instead of HTTPS. So this is one of the issue that's most common, that's still identified on a lot of production applications. So here is a sample screenshot. I just took it from the internet. What can go wrong here? If anybody is sniffing over the network, he can that attacker can see your credentials, what is being transmitted from the client side to the server, and he can even manipulate the communication between the client and server as well. Next up, all right, this is where the good stuff start and the fun stuff start, and this is where we actually look into the code level implementation. What can go wrong at the code level implementations, authentications, and session management. All right. Most common issues while we identify during the pen test is related to this session ID management or logout management things. For example, when you try to log into to an application, what happens in the background is you provide your credential, and a server process it and it checks if the user credentials are valid, and then it sends you back to some other page and sets a cookie in your browser. So the next time you try to access any of the page of that application, you provide the browser provides that cookie as well. So server can identify that the user is already authenticated and does not need to provide the credentials again. So as we can see here, the first step was the user logging into the application. The server redirects the user and sets a cookie, and then the user visits another page where he can see his profile information, and server sends back. This is the usual behavior. And here's the attacking scenario. When the user logs out, server fails to invalidate the cookie but redirects the user to login page. So the user tries to access the page again, and he can access the information or view the information again, because a server or the programmer forgot to invalidate those cookies. Excuse me. Sorry. So the programmer basically forgot to invalidate those cookies that were set at the time of login, and since those cookies were valid, server would gladly process all the requests from the users, even when the user clicked on the logout button or logout function, and will gladly provide all the information to user, regardless if the user is authenticated or not, because of this issue. So we will quickly look into dummy code, what it looks like, and how we can fix it. So here we have code base or a dummy code. Basically what it is doing is if we can see, this is a function or action, you can say. It's basically checking, it's basically used for viewing your profile information. All right, and it checks for different parameters, where it's processing email ID as from the user as input, and sending the response back to the users. But the problem here is at the logout button, we only use session.clear, which will not invalidate the the user sessions even after logout properly. So in order to fix it, we have to remove the cookies and set a blank cookie and destroy the cookies at the and make sure that the cookies are destroyed before login, and when the user is trying to log in, make sure that user does not have any previously stored cookies. We have to clear it manually, and at the logout instant, we also have to make sure the same. So this is the actual page. Sorry, I have to like go back and forth in order to explain this example. This is the controller view, and this is the actual user view. So this page is not checking if the session is valid or not, and because of that, a user is able to access this page, which he was not supposed to access before logging in. So a simple check that if the session is valid or not, we can based on that we can decide if the session is valid. We can redirect the user, or if the session is invalid, we can redirect the user to provide his credentials again, so he can access this page. So just by skipping a check here, we introduce a vulnerability that can lead to information disclosure. Notice here we are not checking the session as highlighted in the red box. This could have been mitigated if the developer checked the user session is valid or not. So let's say the user the request got processed and it hits this function in the controller. So here we have another issue which we will discuss later on, but combining those two issues, this provides a very severe vulnerability. You can access and retrieve information of users without providing any login, without knowing any valid login credentials. If at the end of the talk, if we have enough time, we will get into the demos as well. So how do we fix this? The fix is quite simple, and what we have to do is to make sure that the pages are well protected, and the pages should check if the user session is valid or not. In this case, how I mitigated this issue, I implemented a simple check based on the email IDs, because if I was storing email ID in the session variable, and if I checked if the session variable contains email ID or not. If the session does not contain email ID, that means the session is invalid or the session is blank. So it will redirect the user to log in. At the time of login, I was saving email ID in the session variable. So this way it can be mitigated. Similarly, if we can see on line number 120, a simple check on the session variable, since we are saving the session variable at the time of login. A simple check if the session contains email ID or not could have mitigated this issue. All right, broken access control. All right, so this is more this class of issues often called insecure object reference. Sometimes it is referred to as broken access control. Sometimes We call it elevation of privileges because there are multiple names for this class of bug, depending upon the situation. If the user one, let's say, it could be called elevation of privilege if a not an unprivileged user can access or modify information of a privileged user in the web application. In that case, it is usually called elevation of privilege. uh, uh, I mean, horizontal elevation of privilege. Sorry, it's vertical elevation of privilege. If a user can change or view or modify information of the same role. I mean, let's say there are two users who have like same rights, but user one can modify or view information of user two. This is usually considered as a horizontal elevation of privilege. This can be mitigated by implementing by implementing a proper access control. The code example or the dummy code we are going to look into is quite similar to the previous one. So just before we go into the code, here is an example, an illustration. So let's say a user tries to access following URL example.com index.asp !id is equals to 1, and the server responds back with welcome XY user XYZ, and when the same user or the attacker tries to manipulate the ID value, the server responds back with a different value. And shows the information about different user. So this is a very trivial example or simple example for broken access control. I hope everything is fine, because the screen is flickering at my end. So I just thought I should check if there is an issue with the viewers as well or not. Let me check quickly. Right. Right. So again, back into the code. This code is very similar. In fact, it's a copy of the previous code, and we are looking at the same example here. This function is basically checking email ID, and based on that, it will return profile information, and a user could view his profile information if he provides his email ID. But what's the problem here? The problem is there was no check implemented by the developer, and that makes sure that the user is providing his own email ID, or if he's providing someone else's email ID. There was no check at all. So what will happen is, let's say that there is a user user1@example.com. If he wants to view his information, he would type in user1@example.com, and this would flow through this function or action, and it will return the results for user one. But if the user one tries to pass user2@example.com, the function would gladly return all the information about user2 as well. Why? Because there is no check implemented there to make sure that user one is actually requesting his information, or user one is trying to view someone else's information. So in this case, we can simply check, we can simply implement a small check by again by tagging email ID. For example, let's say I marked email ID as a primary key and I saved it in the session variable. So I can use that same email ID to check if the user is trying to view his own data or someone else's data. So when the user submits the request, he will also submit his cookie, which will be matched against the session ID. So the server will check what value is there in that specific session ID, and what value or what email ID user has provided to check. So this way he can the developer can check if the user is trying to view his own ID, his own details, or if he's trying to view the details of some other user. All right. Okay, I missed a few things about broken access control. What could be the implication in this case? All right. Depending upon the implementation and depending upon the implementation, the impact could vary. Let's say if the if this is a view only, it still can leak a lot of information about the users. Let's say the user could just manipulate or tamper the parameter IDs to view details of all users stored in the applications database. It could get even worse if if such kind of access control is missing while updating user information. This way, an unauthorized user can update data of another user of the same application, which is sadly quite common uh, uh, in applications today. All right, good old SQL injection. I think I really don't need to like dive into what is SQL injection and what could go wrong here, what can be done with SQL injections, but I would still reiterate a few things about SQL injection. So why does it happen in the first place? It's usually because of the lack of input sanitization, input validation, and an untrusted user input becomes part of developer's SQL query, which an attacker can exploit to modify the data or uh, retrieve the application data, or sometimes if the database is misconfigured or is running under a higher privilege user, this can also result in a complete compromise of the application server as well. How it can be avoided? It can be avoided in multiple ways, like we can use input validation, we can use parameterized queries, and we can use stored procedures, but again, those all have their own constraints while implementing. So I'm just going to demonstrate a very trivial example where an inline query was used and how it can be mitigated by using a parameterized query. Okay, so here's here is an example code. Basically, it's processing a user input, and as you can see on line number 56, there is no input validation performed on the ID parameter value, and this way an attacker can terminate the developer query and append his own query to extract data or modify the data, whatever he wants to do. So in order to mitigate this issue, we can use prepared statements. Here's a simple example. I'm sorry, just hold on for a minute. I'm really sorry, guys. That's my niece. All right, so we were on SQL injection. So this way, if the developer used a parameterized query, he could have prevented. Again, if we at the end of the talk, if we get enough time, we will get into the demonstration as well. Template injection. Oh, all right. This is an interesting topic. And what happens is nowadays we are use a lot of web applications are using templates, template engines for a lot of data processing. Let me just give me a. Hello. All right. Sorry. That was my niece again. She just got up. So, the kids. So we were discussing template injection. All right. So this happens because an untrusted user input gets passed to the template engine, and depending on the template engine, there are a lot of possibilities. It can result in server-side code execution, and in some cases client-side code executions as well. So how it can be avoided? Again, it can be avoided by implementing some sort of whitelisting or input validation, or you can implement regex to avoid such issues. And here is an illustration. For example, user input is passed to the web application server, and it gets processed by the template engine. It will send you back the results. In order to detect it, an attacker would try to send something like at the rate curly brackets and then some mathematical operation, and then it would check what's the response of the application. If it gets evaluated, if this 7 static 7 gets evaluated, that means that a template engine is in use, and probably the input is not being validated properly. So I borrowed this code from internet, and I've clearly given credits who actually wrote a blog about this one. I'm really sorry I couldn't remember the name of the guy who who wrote this blog, but I have mentioned his blog and his GitHub as well. So basically, this code is an implementation of his code. But here what we are doing is as basically it's taking input from the user, and the template engine is processing the user input without any sort of input validation at all. So here we can see the string name gets assigned from collections, which is passed from the client end to this code. And uh, if we basically filter out these factors, we could have avoided the server-side template injections. All right. Another class of bug is command injection. It is again caused by the lack of input validation. In this case, what's happening in the back end is the user inputs becomes part of operating system commands as an argument. In most cases, sometimes it is used to launch a specific commands or run a specific command. So what happened is, for example, let's look at this one. So there's a page where you can go and type an IP address or type a domain name, and the server will go and try to ping that domain or IP address. But if the user input is not validated properly, what an attacker would do is he would append special characters or Windows operating system meta characters that are used to terminate or indicate that there is a new command. For example, in this case, an attacker could simply implement ampersand and then type another command to execute a calculator, or maybe a PowerShell reverse shell. So how would it look like in terms of code? So here is a very simple example. This function is basically processing user input. As we can see, the variable IP gets assigned the value from which is submitted from the user end, and since there was no validation, it could easily result in code execution at line number 48. So how can we fix this? We could have fixed it easily by implementing a regex and a whitelist, which basically says allow all character from A to Z and 0 to 9 dot and dash, because you have dots and numbers, and domain names usually contains dots and names and dashes. I'm not talking about IPv6 here. Otherwise, we could have added colons as well. All right, XML injections. This one is an interesting class of bug. There are a lot of libraries that provide XML data processing. We will look at one specific implementation, and we will see how easy it is to fix that XML issue. First of all, why does it happen? It happens because the user, the parser, the parser are not configured properly, or they are allowed to load external entities, which results in information leaks and denial of service attacks or resource draining attacks, and CPU hogging issues, things like these. How we can avoid these kind of issues, we can disable DTD loadings and use safer implementation methods. It's time to like quickly dive into the code as well, and we will quickly look at what a vulnerable code looks like and how we can fix it. But again, just before we hop into the code, let's look at a basic illustration. I don't know, but I just love creating these user and web app web server interactions. So basically, here's an example. User is providing some data, and server is processing it and sending back the results. But if the user tries to introduce his own entities and send it to the server, if the parser is not configured properly, it would process all those entities, external entities, or and send back those as part of the result. In this case, we are trying to access HC host files, and then it can lead to information disclosure. If that was a real world attack, attacker would probably try to read your web.xml. Pardon me, web.config files, or maybe SAM backup files. There are a lot of things that can go wrong in case of information disclosure. So again, this code was taken from GitHub and modified, but I would like to mention where I actually stumbled upon the code and modified it according to my needs. So let's look into the function.
Just wanted to give a quick update. I know that you're winding down. We did have one question from an attendee, and I was wondering if you had time to take that before you wrapped up the presentation.
All
yeah.
right.
So the question was, what tools are you using to test when you start to try to break .NET applications?
All right. So from the testing perspective, I basically use Verb Suite and a few extensions. That's more than enough to test web applications. And if you are looking into the code side, then Visual Studio along with some code scanning tools, but again, that's I won't go into the static scanning solutions because they a lot of false positive, and well, that's another debate. But typically, I use Verb Suite for the assessment. And if you are trying to recover the code, then .peek and Telrix have great tools to recover the source code, and you can do the manual code auditing there as well. All right, so we were at XML attacks, right? And right after XML attacks, we were looking into this dummy code. So this code is vulnerable to XML attack, and just one line of change, one minor change could have mitigated this issue. If we set the .xml resolver to null, it could have prevented XML external entity injections attacks in this case. This is one of the most prevalent issue. Again, it happens because of lack of the input validation, and this is not as severe as the server-side code execution, but it is still severe and has been used in a lot of high-profile attacks as well. We will quickly look how it looks like. And so an attacker basically sends a malicious script to the application processes it and stores it. And when the attacker visits that same page, the scripts get executed in the user's browser context, and that script can send users cookies to attacker or perform attacks or perform different kind of attacks. For example, internal system scanning, or maybe perform actions in the applications.
Hi, sorry.
How we can mitigate it? Yeah.
Sorry to interrupt. Owais. Time is like up. We are over time. So
All right.
yeah.
Just give me 2 more minutes, so I will just wrap this up.
Okay.
I just want to talk about the mitigation of cross-site scripting. So I hope you don't mind.
Yeah.
All
Thank
right.
you.
So how we can mitigate it? The mitigation is quite simple. In this case, we can use uh, do not use HTML.raw methods while echoing out the user input, and use input validation. Again, HTML provides great mitigations against cross-site scripting attack, but if the user input is landing somewhere in HTML attribute, it won't save you from those attacks. So always be careful while using HTML.raw. All right, that's all I have to share. Any questions? So